Well, hello again. This is your friendly neighborhood Dr. Bunsen the Honeydew. Starting to get a cold, I think. Anyways, I thought I'd make a real quick short video here. You can hear the motors running. And I've made some modifications here. I've done a 555 timer circuit, which you can see right here. That is a variable frequency, variable mark space type setup, and it's working quite well. The motor is currently running at about 3600. I think it's 36 maybe. I'll check it again here. Yeah, just a little over 3600. You can also see these PVC T-tubes here being held on to the base by a magnet inside the 1-inch magnet inside the downward pointing T, and about 18 3/4-inch magnets stuffed into the one side of the core, one side of the smaller part of the T going off towards the tower there. And there's my, I got a new 1-pound roll of 22 gauge copper magnet wire with a 3/4-inch cold rolled steel core, which I don't really think it's not a very good type of metal to use. It's generating a fair amount of voltage. With no load, it's about 13.6, 13.7 volts AC, peak to peak. DC with no load is about, I don't know, 9-10 volts. There's the other set of magnets on the other side, on the two towers opposing each other. Again, the two hall magnets, hall sensors, and those are switched, as you can see right there, a little switch for the 2-speed transmission, and I've added, of course, a different power supply. Instead of using a 12-volt PC power supply, I'm using a 140 volt, 0 to 140 volt variac, running into a 25 amp 1000 volt bridge, and then I've got these two gigantic Fender power amplifier caps, 39,000 microfarads each, 80 volts or 85 volts, which are very nice. And then I've got, you can probably see there's some little diodes there sticking up out of the board beside the other two caps there. Those are basically just rectifying, it's another bridge rectifying the power coming off of the generator coil, running through two 10,000 microfarad 35 volt caps, which I believe are actually photo flash caps, because they don't seem to die very fast. They hold their charge for a very long time. I also have a little 12 volt 700 milliamp fan running as part of the load, and I don't know why my LEDs aren't working here. Probably because I didn't plug them. Yep. Alright, so we can plug those in. So, we got some bright lights there. We'll turn them off for now. What I'd like to show you is how this transmission works here. And there's the waveform on the scope. Actually, I'll flip that back on there real quick. that's the waveform. It's about a 20.3% duty cycle at about 400 and the scope says about 450, but it's dancing all over the place. But I calculated it to about 433 and change. So let's slow this puppy down. I'll put the transmission is in. Where is it now? Where's that switch? It's in first gear. So now we're going to spin this puppy up and go. So that's first gear. Second gear. We'll have to disconnect the load for a minute here to let it get some RPMs up. And we're looking at about 13.2 volts over there on that meter, which is the driving voltage, and about 0.9 amps. I don't know if you can see that or not. I'll turn the backlight on. No, that doesn't work. Wait till that goes off, and then I'll just tip it up there. Yeah, there you go. You can see 0.9 amps. Now we're at we're in second gear. Now we're going to switch back to first gear, and away she goes. So that was switching back and forth between a Hall sensor probe that's angled at 90 degrees and one that's angled roughly at about 45, maybe a little less. Right now it's on the back on the 90 degree angle. We're looking at about 13.5 volts, and the current came down to about 0.75. Once the thing ramps up to top end here, it'll probably roughly even out around 0.7 and a little lower than 13 volts, so it comes out to about roughly 8 watts. And we can add some load here. If I can get this right. There's the fan running. And the lights running. And the current is about 0.75. It'll still come down a little bit. It'll roughly even itself out to about 8 watts. Here's the shot of the scope again, the waveform of the 555 timer output, about 20% duty cycle. And that's about it. Sorry my trusty lab assistant Beaker wasn't here to add to the proceedings. He's busy snoozing somewhere. He's probably snoring. Anyways, till next time.